Hello, my name is Steve Quern. I'm the creator of the Firefly project, and I am creating a video of a non-Firefly project spacecraft design. It's known as the STQ Spacecraft design. This video is part of a series that shows the process of making a spacecraft design. Based on my spacecraft design theories that I use for the Firefly project and my personal spacecraft designs that are not related to Firefly project. Let's see here. At this time, this spacecraft design concept does not have a mission role, such as outer space exploration, planetary exploration, mercantile trading, outer space tourism. I'm not interested in designing a weaponized spacecraft, so I'm not saying space fighters or stuff like that. This is a non-combat space vehicle. Most likely going to be an Outerspace RV or an Aerospace Yacht type spacecraft design. So I have everything that's needed for creating object stuff. The measure cube and measure sphere are tools for helping me understand the size and dimensions of objects and spacing between objects and stuff. That'll come in handy. I use these a lot on my PRISMA3D projects. I have here, okay, so yeah, that's what these are. The cube and a sphere. Those are the measure cube and measure spheres. This is represented. The white is the astronaut volume for astronauts, and the see-through is the frame structure for planetary space. The frame structure is 1 feet by 1 feet thick. The astronaut area volume is 4 feet by 4 feet by 8 feet. It allows for EVA, that EVA suits to be worn inside the spacecraft. Also allows for shirt sleeve environment clothing for astronauts to wear. It's a standard. That's my standard human volume for spacecraft. So this video is going to focus on the main engine structure and the main engine module. I already have a STQ motor, 4-foot motor design, so we're going to look for that. There it is. And that's the center of the, okay. Okay, since I don't know what I'm doing for the spacecraft design, I'm starting out with the engine structure. So I got the 4x4 motor. Now I need now I need to do is make the engine module. The reason it's a 4x4 engine module is because of the human volume area. And let's see here. The engine module, let's do this. Oh. Okay, oh. Oh, okay, never mind. Okay, that's at negative 50, sorry. Because this area here, the spacecraft line is a 50 by 50 area. And that's the center point, and this text is 25 to the right. And then we got that, this is 50 to the right. And the center point is right here. Okay, so okay. So you see that motor inside the human sphere. And you can see that. So let's put it back. Okay, the motor is 4 feet, so we're going to add 2. Then the nozzle is 8 feet, so we're going to add another 8 to that, so that's going to be 10. So let's see here. So we're going to make the engine module. We do not want to do that. Here. No. Now this is going to take there we go. Okay. The reason I'm calling this the Hi Allie. Okay. Oh girl, how you doing? Okay. I call this the STQ 4.0 engine because it is not the same thing as the STQ, the F1 STQ engine. Although in my fragile project I do use the same size, the Apollo Saturn V F1 engine is actually closer to 4 feet 6 inches in the XYZ dimensions than the 4.0 feet that I use for my fragile project drawings. I use the 4.0 measurements because the graphics is easier to manipulate, and the detailed graphics of the DeltaCAD 3.0 had accuracy of 1/16 of an inch. This PRISMA3D has an accuracy of 1/4 inch, and Blender 3D had the same thing, accuracy of 1/4 inch. They're designed for the metric system, and I'm using the American English system. So that's the problem right there. Okay, name. STQ 4.0 inch nozzle exterior. Into these dimensions. Made punch engine nozzle. Okay, so save it. And then it has to go up for. Alright, let's see here. Ground level is going to be hidden. I got a little bit. .9. Yeah, 3.9. fix. Here we go. Okay. Here we go. Okay, now we're going to duplicate that. Make the interior. I do not know how thick the nozzle structure is. Copy. So I'm going to just shrink down it by 1. So these nozzles are going to be 6 inches thick. So that's if the F1 engine nozzle was. How thick the engine nozzle on the F1 engine is, I don't know. But I'm making a guess and to make it look good. Now, let's see here. Inside the exterior. And inside the motor. Make sure I didn't screw anything up. Okay. So this is the interior, so we're going to get rid of everything. here. I did this in Blender, and this is PRISMA3D works very much similar to Blender, but does not have the same level of detail. So there you go. So now, we're going to need to length this a bit. Okay. Every once in a while, the app freezes up. Since I cannot activate that thing, I'm going to have to exit, save the program for a bit, go home, close it out. Reopen it. See, okay, and that's the same button. There we go. Can you see? Okay. Now, hopefully you can see the detail. Yeah, you see that. Now I can see where the inner is. And you can see where the inner begins and ends. And so, now, the exterior nozzle. Okay, we're going to okay, that should work. And we're going to size that. There we go. Bye-bye. Mm-hmm. And look at today. Alright. Look. You now have external nozzle. And then you need to fix that measurement. Okay, there's a little gap. I should have listed it. Okay, yeah, what happened was I should have left it. Okay. Alright. Okay, that's good as it's gonna get. I'm not gonna mess with that anymore. And so we now have okay, we'll have to save it. And we need to relocate that back to where it's supposed to be. And you can see the engine from there. Okay. So this is what we got. That is our project for the time being.